Hi guys, this is Mrs. Lyons. Today we're talking today we're talking about combustion reactions. Combustion reactions are when we have a hydrocarbon combining with oxygen. The products in a combustion reaction are always carbon dioxide and water. Okay? And the thing that we need to know is, what is a hydrocarbon? A hydrocarbon is going to be some compound that contains carbon and hydrogen. All of these that I'm writing would be examples of hydrocarbons. Sometimes hydrocarbons even contain oxygen. Okay, the main thing is that they have carbon and hydrogen in them. Okay, so anytime you see any of these compounds, and there are millions of hydrocarbon compounds, you should identify that reaction immediately as a combustion reaction. And the reason you should identify it immediately, it's also, the other clue is going to be it's reacting with oxygen. Now, the cool thing about this is, once you've identified a combustion reaction, there's really no more thinking to do, because the products are never different. The products are always carbon dioxide and water. Okay, so let's think about this. I have this reaction, C2H6 plus O2. I immediately identify this as a hydrocarbon plus oxygen. I don't have to think about anything. I don't have to balance charges. I don't have to think about Hoberfinkel. I know my products are carbon dioxide and water. So why do we even bother with these? These are simple, right? Well, here's the thing with hydrocarbon compounds. We have to balance them. And when we balance them, sometimes it gets a little tricky. So I want to go through each one of these examples. I want to balance with you. When you balance hydrocarbon compounds and combustion reactions, I want you to think, we always use what I call the CHO method. CHO. C-H-O. And if you remember CHO, and I know there's no real reason to remember it, but remember CHO, combustion reactions balanced by CHO. We're going to balance the carbon first, then the hydrogen, then the oxygen. Okay, so let's start this out by figuring out how many of each type of atom I have on each side of my equation. So carbon, in my reactants I have 2 carbon. In my products I have 1. In my reactants I have 6 hydrogen. In my products I have 2. And in my reactants I have 2 oxygen. Over here I have 1, 2. Don't forget the 1 in the water, so I have 3 oxygen. So using the CHO method, we're going to balance carbon first, which means we have 2 carbon on this side, 1 on this side. I need to put a 2 here. That gives me 2 carbon, and then count them up. I've got 2 times 2, I've got 4, plus 1, so I've got now 5 oxygen. Next we're going to balance hydrogen. CHO method, hydrogen comes second. So over here I have 6 hydrogen, over here I only have 2. So to get 6 hydrogen, I need to put a 3 here. Now, that gives me 6 hydrogen, but I want you to think about something that causes us problems in combustion reactions all the time. Notice if I have an odd coefficient here, I'm going to end up with an odd number of oxygens always on my product side of my reaction, right? Can I ever have an odd number of oxygens if I've got O2 over here? The answer is no, because we can't use fractions as coefficients. We can't put 0.5 O2s. So anytime you end up with an odd coefficient in front of water, I want you to automatically just go back and double it so that we have an even number. Okay? Now this is going to cause us to do a little bit of back stepping, but let's just go through this process. So now I have 6 times 2 hydrogen, so I have 12 hydrogen over here. So I want to get 12 hydrogen over here. That means I need to have a 2 here. 2 times 6 gives me 12 hydrogen. Notice my carbon are no longer balanced. Now I have 2 times 2, so I have 4 carbon here, which means I don't need a 2 here, I need a 4 here. Let's erase that. Do I have an eraser? Yes, so let's erase that. And let's put in a 4. Now let's go and figure out. So we've got 2 times 2, we've got 4 carbon. Here we've got 4 carbon. We've got 2 times 6 for 12 hydrogen. 6 times 2 for 12 hydrogen. Now let's figure out how many oxygen do we have. Over here we have 4 times 2, that's 8. But then we've got to count the water oxygens also. So 6 times 1 is 6. So we have a total of 14 oxygens. The good news, that's a nice even number. So we can balance that over here. We have 14 oxygens over here. What coefficient do I need? I need a 7 in front there. That gives me a balanced chemical equation. Okay, 2C2H6 plus 7O2 yields 4CO2 and 6H2O. Okay, let's do another one of these. So we've got C6H14O2. Now, the easy part, our products are CO2 plus H2O. That's the easy part. Now we're going to balance. We're going to balance using our Cho method, carbon, hydrogen, oxygen. All right, so let's count. We have 6 carbon and 1 carbon. We have 14 hydrogen. Over here we have 2 hydrogen. And then we've got 2 oxygen. Here we've got 3 oxygen. All right, so let's see. We're going to start with our carbon. 6 carbon. We need to put a 6 coefficient here. That gives us 6 carbon. It also, now add up the oxygen, it gives us 6 times 2 plus 1. Gives us 13 oxygen. Now, what about our hydrogen? We have 14 hydrogen here. So what number, what coefficient do I have to put here to give me 14 hydrogen? I should put a 7, right? 7 would give me 14. But remember, that's an odd number. We can't have odd coefficients in front of water because it will never balance. So we're just going to double that. Okay? Someone asked me once, can we have big numbers in these, Mrs. Lyons? Yes, in hydrocarbon combustion reactions, you're going to have big coefficients sometimes. So now we've got 28 hydrogens. All right, so we have to go back and we have to balance. We need to get 28 hydrogens on our reactant side. So that means we need a coefficient of 2. So now our hydrogens are balanced. We've got 28 on each side. We've also now got 12 carbons because this 2 coefficient multiplies by this 6. So 12 carbons, which means we need to change this coefficient to a 12. Okay, so now let's add up. We've got 12 carbons over here, 12 carbons over here. So we've got our carbon balanced. Oxygens or hydrogens are both 28. Now we just need to get our oxygens figured out. So how many oxygens are in our products? 12 times 2 is 24 in my carbon dioxide, but then I've got 14 waters, so that means I've got 14 oxygens. So let's see, 24 plus 14, I have to do the math, is 38 oxygens. So let's see, what number is going to have to go here to give me 38 oxygens? 38 divided by 2 is 19, right? So that gives me 38 oxygens. So yes, we're going to get some big coefficients. Our coefficients are 2, 19, 12, and 14 to balance that combustion reaction. Let's do one more example, and we're going to do an easy example for our last one. Okay, so we've got methane. This is what burns in your Bunsen burners. CH4, we call that methane, is its common name. Reacted with oxygen. Okay, again, the easy part. Our products, CO2 plus H2O. We need to balance using the Cho method, CHO. So let's count. We have 1 carbon in our reactants, 1 carbon in our products. we have 4 hydrogen. Here we have 2 hydrogen in our products. And then we've got 2 oxygen and 3 oxygen. So our carbon's already balanced. What about our hydrogen? Let's see. We have 4 in our reactants, 2 in our products, so we need to put a coefficient of 2 here. Now notice it's an even number, so I don't have to do anything with it. I'm happy, happy, happy about that. Never happier than when I get an even coefficient, because it means, look at that, my carbon's balanced, my hydrogen's balanced. I can just balance my oxygen and this thing is done. So let's see. I've got carbon dioxide, that's 2 oxygens, and then I've got 2 from my water. That gives me 4 oxygens over here. So I simply need to put a coefficient of 2, and I've got 4 oxygens over there. And guess what? I have a balanced chemical equation. So you're always going to be really, really happy when these balance and you don't have to do that whole doubling thing and figuring out an even coefficient. But that is combustion reactions. I hope that helps. I will see you in class.